Hey guys, welcome back to my channel. So this video is going to be about clean and dirty prices. It's quite a, I guess, quite a well-known concept in the whole world of bond pricing, but it's something that can be a bit tricky to get your head around, especially when it comes to, you know, where the accrued interest fits in with it all, and when you're looking at a price, is it the clean, dirty price? How to determine it? And what each of them represent. So we're going to go through a kind of the basic concepts around the cash flows, discounting the cash flows back to a settlement date that's sort of halfway through a coupon period, talking about the accrued interest, and obviously, it all comes down to present value in the end. And then in the next video, I'm going to give you a demo of an Excel tool I've put together that actually you can download yourselves and play around with, and kind of see how it all fits together. You can play around with the numbers and the formulas. But it's really to show you how the Excel based calculations work. So let's get started. So this is a common scenario that we've all seen, right? So the bond yield in the previous video we saw is basically it's the discount rate which we use to discount all of the cash flows, right? PV or the price, right, equals basically the present value of all of the cash flows discounted back to present, right? So the present where time equals 0, right? And these are all basically let's say 1 year periods, right? So let's say it's an annual coupon bond. This is 1 year. This period is 1 year. This is 1 year. This is 1 year. This is 1 year. This is 1 year. So this is a bond with 6 remaining coupon periods, and the principal coming at the end, right? So this is a very simple example because all the cash flows are being discounted by a sort of a discrete and whole number of periods, okay? And that so this can apply to calculate the initial price of a bond on the day it's issued, because obviously that is also an integer number of periods between that present moment and the maturity. Or it can also be a valid scenario for pricing a bond on the actual coupon date, right? So basically, at the beginning of the next period, then all these formulas we've been using so far to get the bond price. If you remember the formula, if I can remember, was something like it was C times 1 minus 1 over 1 plus I to the n over I plus the maturity, right, divided by 1 plus I to the n, right? So basically, that's the price using a discount rate or a yield to maturity of I with n number of periods. That's what we've been used to up until this point. But see, what happens when the bond is actually traded not at this point here, 1 full year away from the next coupon, but let's say it's traded halfway through the next coupon period, right, at this point here. So in that case, what is the fair value for the bond? What's the price of the bond? It's no longer the first cash flow is now 6 months away from the present, not a whole year, right? So the first cash flow, which previously we would have been discounting at basically, so PV for the first cash flow was previously the coupon divided by 1 plus R, right? Where R is the yield for that periodicity. So the 6 month yield if it's a semi-annual bond, or the 1 month yield if it's or the annual yield, sorry, if it's a annual paying bond. And let's assume for the simplicity here that we're dealing with an annual paying bond. But now, and that's strictly speaking, it's to the power 1, right? And also, the PV of the second cash flow, right? Second cash flow equals coupon divided by 1 plus R squared, right? Where R I is the same difference, right? R we're saying is the yield to maturity. and 2 because we're basically discounting for two full periods. So these two scenarios are for when we are pricing as of t equals 0 years, right? So basically, so one full coupon away. And the only difference we here actually is it's quite straightforward. The present value of on as of this day here, where we're basically pricing the cash flows as of a day that's halfway through the period, is really a question of discounting all the same cash flows, but back to that date in the middle here, rather than the date at the beginning. And that, it turns out, is actually quite straightforward, right? And the way you actually do that is basically by plugging in a for each of these cash flows, right, a non-integer value for the exponent here, right? So let's say, for example, and I'm not going to go into exact days here, but let's say that this is basically halfway through a year, right? So the bond is trading, the bond is trading, so changing hands halfway through the year from one person to another, and the person who's buying the bond has to basically ask the question, what is the present value of all of these cash flows that I'm going to receive from today, right, halfway through the period? And so again, instead of doing discounting up until t equals 0, he's discounting up until halfway through the period. So the what he does is basically he uses the fractional time of the year, right, of 0.5 for the first cash flow, right? So let's say, so basically for the price as of t equals 0.5 years, right? So where our blue dot was, right? Blue cross on the screen. So the price as of t equals 0.5 years is basically, so for the first cash flow, the PV of that first cash flow is as follows. It's basically C divided by 1 plus, I'm going to call, instead of R, I'm going to write Y, like Y for yield, right? So 1 plus Y to the power 0.5, right? And then the PV of the second cash flow, which is basically this one here, right, is C divided by 1 plus Y to the power 1.5, right? So all the exponents, right, have basically been shifted up by 0.5 years, right? Because our discount point that we've discounted to has moved closer to the time that we're actually going to receive them. Okay, so so basically the present values are getting higher, right? Because the exponents which are on the denominator are getting higher, right? So these cash flows are getting more valuable because we're getting closer. We're 1 year closer to receiving all of these cash flows now. Now, so the question is, first of all, how do you actually calculate what that fraction is, right? Because we said, for example, I'll just zoom in on the scenario a bit, but we had a timeline, right? So this was year 1, this was year 2, and our trade was happening halfway through the period here. In actual fact, you know, when the bond trades on whatever day this is, we'll be using things like day count conventions to make a very precise assessment of exactly what that fraction is. So what fraction through this period have we reached when the trade happens on the blue cross there, right? And if you remember, in the life cycle of the bond, we talked about basically the trade date, right? So trade date is the date on which the two parties agree a price and agree basically to legally transfer ownership of the bond, and then the settlement date, which is depends on the region, but let's take the US as an example. 3 days time, right? You have the settlement date, right? And then so on the settlement date, on that day, the money changes hands between the parties, and the registered ownership of the bond transfers from one party to the other. So that's the actual date from which all of these prices and valuations and discounting happens towards, right? It's the settlement date. Okay, So now it's time to talk a little bit about accrued interest, which I think we've mentioned in previous videos a little bit, but just to sort of reiterate. So accrued interest is essentially it's an estimate of for a given period. So let's take this period here. So the period between t equals 0 and t equals 1 year, right? It's basically within that period how much of the interest for the eventual coupon payment that is going to be made has actually already accrued. Let's say the coupon payment we're expecting is $100, right, at the end of this 1 year period. And let's say, so our buyer here is basically, he's holding the bond for the first 6 months of this 1 year period, right? So basically he would quite justifiably argue that that basically he needs to be compensated somehow for the fact that he's been holding this bond for that time, right? This is the what's called the accrued interest, right? And basically what we see is that if this happened exactly halfway through the period, then essentially the price that the buyer ends up paying the seller will reflect the fact that the seller has held the bond for the first half of the year. So the accrued interest in this case would be the coupon payment, which is $100, multiplied by the number of days between the last coupon date and the date of the settlement, basically the date to which we're calculating accrued interest. So basically days to, can't think of a way to write this succinctly, days to settlement from last coupon. This is a bit of a recap, we've covered this in previous videos, I know, divided by the total days in the coupon period, right? So often, and this here will depend, will depend on the day count convention used, right? So if it's 30 over 360, then basically you'll count the number of days to the settlement from the last coupon as if each month had 30 days in it, and the total days in the coupon period would be counted as if there are 360 days in the year. And so basically, so that's the accrued interest. Now, how is this important? I spent quite a while, when I first learned about this, sort of trying to get my head around the concept of the buyer compensating the seller with accrued interest that the seller has actually accrued, right? The simple answer is, if you ask the question, how much is this bond worth, and therefore what's the fair price for the seller to charge the buyer, right, to buy the bond? It's ultimately as simple as what is the present value of all of the cash flows that the buyer is going to receive, right? And that's it. That's the fair price. Now, as long as the bond is trading come coupon, right? So come coupon, what that means, right, is that the bond is, so that when the trade is done, right, when the bond changes hands at whatever date this blue cross is at, right, when the bond changes hands, if the bond is trading come coupon, what it means is that this next coupon goes to the buyer of the bond, right, not the seller, right? So in a trade, when a bond changes hands, if the trade is basically done come coupon, it means that the buyer of the bond will receive the next coupon. What does that mean? That means that the price that the buyer must pay includes the present value of the coupon discounted back to the settlement date of the trade, right? And then obviously all the other cash flows then also get discounted back to the settlement date as well, right? So that price of the PV, right, of all the cash flows to the settlement date, excuse my handwriting again, I keep saying it, right? That is called the dirty price, right? Dirty price. Now, you probably heard this a lot, and dirty price is often quoted as something that's derived from taking the clean price and adding the accrued interest, which is kind of, it's correct theoretically, but it can be a bit misleading somehow in the way it's quoted, because it kind of makes out that you first calculate the clean price and then you separately calculate the accrued interest, and then from those two numbers you get the dirty price. That's not true, right? The way you price a bond is by discounting the cash flows, right? And when you calculate and when you discount the cash flows for a transaction that happens between coupon dates, like this one here, you discount back to the settlement date, right? And that present value from that discounting is equal to the dirty price of the bond, right? So that's your starting point, okay? That's very important, right? So if this dirty price, right, is also sometimes called the invoice price, right? And it's also sometimes called the transacted price, right? So it could hardly be clearer, right? This is the price that's actually going to change hands on the settlement date. This is the amount of money in dollar terms that's going to change hands between the buyer and the seller of the bond, okay? Now, so there are a few characteristics about dirty price that that basically make it not the ideal way to basically measure and quote and compare the movements of different bond prices, and I'll show you exactly why that is, right? So let's take an example of why the dirty price is not an ideal quote or an ideal way to measure and compare bonds with each other, and also to compare the actual performance of a bond, or let's say the underlying quality of the bond, which is obviously reflected in its price from a day-to-day basis, right? So if you think about it, right, so the bond that we've been talking about, right, so we had sort of 6 years to go, right? So we had these coupon payments like this, and like this. So if you buy the bond here, right, during this period, then the buyer is going to get this cash flow, is going to get this one, and all these, right? So all these cash flows come to the buyer, we present value those, and that determines the price. If this bond trades on this date here, which is the first day after this coupon payment happened, right, then the buyer does not get this coupon because it's already gone, right? So the seller already received that coupon payment, and then he sold the bond the very next day, right? So if you compare the value, right, of this bond on the day before the coupon date and the day after the coupon date, they're totally different, right? Because this coupon payment is $100, right? So if I buy this bond the day before, on the last day of the coupon period, I'm going to get $100, right? If I buy it on the day after the coupon is paid, I'm not going to get the $100. So the difference in price, right? The difference in price is basically $100, right? So, you know, just because the coupon is paid overnight, right? I'm trying to find a way to measure whether the performance of this bond is moving because of you know, the underlying rating or the probability of default, etc. But in actual fact, over just the period of one day, the price has dropped by £100 just because the accrued interest that's been accruing over this period here has been paid out on that day, right? So what happens in order to basically find a way to sort of a clean way to report the price of a bond, okay? What is done is basically we take the dirty price and we calculate a clean price from it, right? And the clean price is the dirty price minus accrued interest. Right? And that's very important. And conversely, dirty price is equal to obviously clean price plus accrued interest. Now, by doing this, right, what we do is we have a price, and the clean price is sometimes referred to as the quoted price, right? So the quoted price, this is often the price that you'll see quoted. Let's take, in the US again, bond prices are normally quoted at the clean price, okay? And that's why it's called the quoted price. And that basically is, so if you try and present value the cash flows of the bond using the quoted yield on that bond, you won't get the same quoted price, right? What you're calculating when you present value the cash flows at the yield is the dirty price, right? If you want to basically get the clean price, you have to calculate what the accrued interest is currently on that bond, right? So basically, let's say that trade is halfway through the period, and the accrued interest starts from here and it ramps up to the coupon, right? We have to calculate exactly how much this is, and we have to subtract it from the dirty price. Excuse me. All right, so that's the end of the first part of the sort of the two-part session on clean and dirty price. Just an introduction into the concepts. In the second part, in the next video, which is linked down below, I'm going to give you basically a demo of a couple of tools. One of them being an Excel function, the other being the Investopedia website, where you can actually calculate prices. I'm going to show you how the calculations tie out, and it's going to be an Excel downloadable file for you to basically play around with and see some of this stuff yourself. Okay, so thanks for watching, and I'll see you in the next video.